Hello everybody! Hey, what's up you guys? So, how's it Jared, would you stop interrupting me? I'm trying to do my intro.
You should be thanking me. I'm doing your subscribers a favor.
See, this is why I don't pay you.
Hello my fellow internet explorers, and welcome back to the World Wide Web.
Hi friends. So if you didn't already know, I am currently a second-year computer science major in college. And although there are basically infinite applications to all the things you can do with computer science, one of the ones that's always been fascinating to me and that I've always been curious about is the YouTube algorithm. Of course, we don't know everything about the YouTube algorithm, well, for obvious reasons, including but not limited to the fact that is literally top secret. But there is a lot that we do know about what attributes of a video are favorable to the YouTube algorithm and what makes a video more likely to go viral. And people have discussed these attributes ad nauseum on this platform. I mean, over and over and over and over again. But one thing that I've never seen before is someone actually try to recreate the whole thing. So, ladies and gentlemen, against my better judgment, that is what I'm here to do today. So if you're worried that this is gonna be like a super technical explanation, don't worry. It's gonna be super simple, accessible to everybody. I'm just gonna give like a really high level overview of everything I'm gonna do. Then I'm gonna give you a speed montage through all the writing of the code, and then we're just gonna test it out in the end. So before we write a single line of code, let's start by sketching out the pieces of information that we want to include in our algorithm and how we want to include them. So the first and arguably most important element of the YouTube algorithm is watch time. Now, if I had to summarize what watch time is, I would basically say that once someone clicks on your video, it's the amount of time that you're able to keep their attention before they inevitably click on a Tana Mongeau video about her $100 million sugar daddy.
But his net worth was $100 million.
So watch time is normally represented as a fraction of the video duration. So for our purposes here, we are going to normalize it as a decimal between 0 and 1. So for example, if that number is 0.5, then that means that someone would have watched half the given video. Our next metric that's really important in determining the popularity of a video and how quickly it grows is click-through rate. Now, click-through rate sounds confusing, but essentially all it is when YouTube recommends a video to a certain subset of people, it's the percentage of how many people actually click on the video. So once again, this is normally given to you as a fraction, so we are again going to represent it as a percentage or like a decimal between 0 and 1. So the next important metric is like to dislike ratio, and this one's pretty straightforward. I'm pretty sure you all know what I'm talking about when I say that. So we're once again going to represent this as a fraction of the number of people who like the video as compared to the total number of ratings given on the video. So like the number of likes plus the number of dislikes. And once again, we are going to represent this as a number between 0 and 1. What's up, Jared?
So why are you turning everything into a number between 0 and 1?
Oh, okay. A surprisingly intelligent question coming from you, Jared. So once we get to the actual meat of our algorithm, you know, when we're doing all the messy math and stuff, it's really important that we normalize all these values on the same scale. This way it makes it much easier to assign what are called weights or importance scores to each one of these metrics. And basically all that means is we're going to be assigning a number to each of these metrics that represents how much we care about it, how important we think it is in the processing of any video in the algorithm. But don't worry if that's confusing, we'll come back to it in a little bit and I promise it'll make more sense later. And finally, our last important piece of information for our algorithm is keywords. Now this one is a little bit more confusing, so we're gonna have to break it down into some subparts. So first of all, what is a keyword? And that's a great question. So a keyword is basically any word or short phrase that's really popular on the YouTube platform, so a lot of people are searching for it, and many videos have included it in their title and description. So if someone is trying to optimize their video to do well in the YouTube algorithm, we can safely assume that they're gonna have multiple keywords that are present in their title, description, and tags, and that each of these keywords will be present multiple times. Now, since these keywords vary both in frequency and in how often they're searched by YouTube users, we're going to need to assign a score to each of the keywords using both of those pieces of information. So I'll get into a little bit more detail later, but for now, all you need to know is that we're treating each of these keywords as a separate object, and that each of them is going to be assigned a score that basically dictates how effectively the keyword was used in the video. So now we've laid out all the information that we're going to use, and we've normalized it all to decimal values. But how do we actually determine if YouTube's going to recommend a video, and if so, to how many people? So we're gonna write a little procedure for that together. Based on what I've read about the algorithm, I'm fairly certain it works something like this. So first, YouTube records the data that a video receives immediately after its release, so like in the first 24 hours after it comes out. This includes likes, dislikes, watch time, everything like that. So after collecting that data, the algorithm then crunches some numbers, which hint hint, is exactly what we're gonna be doing next. And it determines if it wants to test the video on a wider audience. If it does, then the video will be recommended to some non-subscribers based on the relevant keywords. This can be thought of as somewhat of a focus group where YouTube's basically testing the video's performance on the general public to see how it fares. If it performs well again, then the process repeats, and so on and so forth until YouTube decides that the video's results aren't doing well enough to continue to promote it, and that's when the video plateaus. If a video happens to continually perform well through all of these iterations, then congratulations, you have yourself a viral video. So yay, now we finished planning our entire algorithm. So what I'm gonna go ahead and do now is just speed run my way through the code writing process, and I'll get back to you all soon to test this puppy out. Let's do it. So basically everything important happens in this chunk right here that's called calc next iteration. Now I know this looks really big and scary, and to be quite honest, it is. But basically, to summarize, what happens is this takes the data from the previous focus group, so from the previous iteration of testing, and it makes a decision on what to do in terms of promoting the video in the next iteration. So right here, you can see the final val and normalized final val. What this does is it takes the data that we talked about earlier from the metrics like watch time and likes, dislikes, and everything that we went through before, and it multiplies them by a set of what are called importance scores. And these are defined up here. So it's basically a relative metric of how much we care about each of these individual things. So for example, we care about the keywords weight metric 100 versus caring about the like-dislike ratio only about 5. So we care about the like-dislike ratio 20 times less than we care about the keywords. So these values don't actually stay static throughout the whole process, because if you think about it, you care about the like-dislike ratio maybe a lot at the very beginning when you want to know if a video is even credible enough to promote. But once a video is really big, you maybe don't care about the like-dislike ratio so much. What you really care about is the watch time and the click-through rate. So those over time, those values would increase, and the values for the like-dislike ratio would decrease over time. At the end here, you can see the code is saying if this final magical value that we've calculated is less than 0.4, then what it's gonna do is spit out this phrase down here that says this video has a low final score and will undergo no further growth. And basically once that happens just one time, so once it fails the final check even once, it will never be promoted again. It's stuck in an infinite loop. And that's basically the code equivalent of saying a video is dead. Like YouTube is not gonna touch that thing. But as you can see down here, if it passes the test, then what the algorithm's going to do is it's going to make a decision of how many people it wants to be in the next focus group. So how large the next group that the video is going to get promoted to is going to be. So in order to track the overall growth of the video, all we need to do is run this bottom little part over and over and over again, and then we will see how a video performs over time. So first of all, sorry, I really wish there was a prettier way to do this, but making a user interface for this would have been literally so hard. So this is what we're stuck with. So as you can see here, I've created a few just test keywords. The first number in the parentheses basically represents how many times that keyword was put in the title or description, and the second number represents how good of a keyword that is. So on a scale from 0 to 1, how high quality of a keyword we're dealing with. Now the giant string of numbers down here where it says video basically represents a bunch of sample data that I'm putting in of how a video performed in its first focus group. So this corresponds to a video with a 35% watch time, 10 likes, 0 dislikes, 50 views, and then the K1, K2, K3 correspond to the keywords, and the 0 is number of clicks, which I'll describe more later. So let's go ahead and run our algorithm, and let's find out if this sample video here is going to get promoted or not. So here we go. 1, 2, 3. The algorithm says no, it will not get promoted. So the algorithm says this video has a low final score and will undergo no further growth. So basically what that means is that the values that I put in weren't good enough for the algorithm to suggest it to more people. Like it had a relatively low watch time, it wasn't viewed by that many people, and all those things contributed to YouTube deciding to not promote it anymore. But now let's try a video that seems to perform a lot better. So this new video has a 75% watch time, 100 likes, 0 dislikes, 2,500 views, and the same keywords. So let's go ahead and try this one. 1, 2, 3, and Yes, okay, so the algorithm says this video will be recommended to 6,008 people and it has current total views of 2,500. So as you can see, when we put in a video that had a much better performance, so it had higher watch time, more likes, more views, the algorithm was more inclined to promote it to more people. But that's not the end. Let's see what happens when we put in more data for how the focus group responded to this second promotion. Now, if you remember, the algorithm said that this was recommended to 6,000 more people. So let's say for fun, in the first number there, that 3,000 of those 6,000 people watched it. Of the 3,000, it had a 0.65 watch time, 150 people liked it, and 6 people disliked it. So if we run another iteration of the algorithm, let's see what happens. So as you can see, YouTube still likes this video. It's now going to recommend it to 14,500 more people. So you can see how this video is kind of starting to blow up exponentially, right? I mean, it started with 2,500 views, and now it's being recommended to 15,000 people after just 2 focus groups. So you can see kind of how a video progresses and how it'll go viral over time. But let's say for argument's sake that this next group didn't like it so much. So as you can see in the first number, out of the 15,000 people it was recommended to, only 1,000 watched it. It had a 10% watch time and 50 likes and 50 dislikes. This isn't very good. So if we put this in, let's see what happens. Oh, and as we can see, the algorithm says this video had a low final score and will undergo no further growth. So even though the video was doing so well, like it was doing great, it was getting recommended to so many people, that new focus group didn't like it so much. It had a really low watch time, not many people watched it, and so YouTube stopped that video right in its tracks, right there. It killed it on the spot. And these are just a few trivial examples of how my representation of the YouTube algorithm works. Basically, you can put in any data, so good data, bad data, and the algorithm will respond accordingly, saying whether or not it's gonna promote it to more people. So I guess if I wanted you to have any takeaways from this video, I would say just remember that the algorithm is extremely complicated. It has so much going on that we don't know about, that even I don't know about. But that's not to say that if you don't really focus on optimizing the things that I talked about in this video, like watch time, like dislike ratio, etc., that you can't give your video a much better chance of performing well in the algorithm. Anyways, guys, I really hope you enjoyed this video. I had so much fun making my own representation of the algorithm. It's something that, as like a computer science nerd, I've always been interested in and I've always wanted to do. So I'm so happy that this gave me an excuse to do it. If you liked the video, please go ahead and give it a big thumbs up. And if you want to see more content just like this, go ahead and click that subscribe button down below to join the Internet Explorer family. I wish you all the best of luck on your cyberspace journeys, and until next time, peace out.